Okay? CJ, look at this right here. Is this going to break up when we write the ionic equation? Why not? That's right. It's got to be aqueous. Both these conditions require that it be aqueous. You don't even have to figure out if it's ionic or acid. Because if it's not aqueous, it ain't breaking up. Got it? What? Okay. Oh, let's see here. Evelyn, will this break up?
Yes.
How do you know?
Because it has a metal in it on it.
So it's ionic,
Yes.
but ionic is not the only condition. You have to have more than one condition to break it up. What's the other condition? It's got to be both ionic and aqueous. And you've identified correctly why it's ionic. It's made of a metal and non-metal. Okay? All right, so you should have identified this one as one that will break up. I said earlier, when we were explaining this, that this is ionic because it has a polyatomic ion. It's also aqueous, so it meets both conditions, aqueous and ionic. This one breaks up for the reasons that Evelyn stated. This one doesn't break up for the reasons that CJ stated. This happens to be ionic, but you can't just be ionic. It's got to be both ionic and aqueous. And this one breaks up because it's both ionic and aqueous, as Ben stated. Okay? So let's go through breaking these up then. Let's go through breaking them up then. I'm going to show you the first one and give you some explanation and then let you try the next one. Alright, before we do that though, let me tell you this. If it doesn't break up, you write it exactly as it appears in the regular equation. Okay? So if it's not going to break up, you don't break it up. You just write what you've got there. Okay? Let's look at this first formula. Let's look at this first formula here. Flip it over and do it on the back side. Give me a little more room. Okay. We've got silver and nitrate. 2 parts. 2 parts. Silver and nitrate. Okay? When we break them up, we pull them apart by their charges. Okay? So what charge does silver have? What charge does silver have, Chelsea? What charge do we give to silver? Huh? What charge does silver have? A 2 plus? Where did you get that from? Silver has a 2 plus? Okay, well help Chelsea because she seems to think it has a 2 plus. Where do you find that? Well, look for it yourself and make sure you found it. You need to practice with this, okay? Find that reference. You see it? Do you see the silver? And what charge does it show in that box with the silver? Okay, so this is going to have a 1 plus charge. Okay? Morgan, what charge do we put on this ion? Oh, Morgan, you got a bad cold or something? I don't know. I heard somebody say the answer, and it sure didn't sound like your timbre. -1. Where'd you get that from?
From the common ion.
Very good. It's a polyatomic ion. That's where you can get those from. The common ions list. Okay.
So you just worry about.
Okay, Zach. The compound in the balanced regular equation shows that this compound is aqueous. What physical state am I going to assign to these 2 ions? Zach? That's a bad echo in here, Zach. I'm hearing from this side of the room instead of your side of the room. What physical state do I assign to those? Really? Okay. Yes, if it's aqueous in the equation, if it's aqueous in the balanced equation, it's also aqueous in the complete ionic equation. So this aqueous applies both to the silver ion and to the nitrate ion. I will have to put a plus between them, yes, but I'm not quite ready to do that yet. Okay? Darrell, how many silvers are there up here? There are 2 silvers. So this 2, when we're balancing the overall equation, remember, there's 2 applied to everything in here. It also applies to the separate ions in there. So there are 2 silvers. Okay, and Daniel, how many nitrates are there?
2.
Doing a complete ionic equation. This 2 applies to everything. Okay? 2 nitrates. Now, Brandon, I'm ready to put that plus sign in between. I don't, but that was where I wanted to do it. Okay? Alright? So now, I have tried to go through this with everybody in the class as a whole class activity, explaining how you figure out how to break these up. Now it's your turn. Everybody, figure out how to break it. We said this is going to be aqueous. This is ionic and aqueous, so it's going to break up. Figure out how to break it up properly.